Welcome to Debug Log, software engineering war stories, architecture decisions, and lessons learned the hard way. Let's dig in.
Okay, so picture this. It's 3 a.m., your pager just went off, a Sev1 is blowing up, and you're staring at 5 different dashboards, trying to figure out if it's the database, the network, or that last-minute deploy from engineering. You're bleary-eyed, fingers fumbling.
Classic. Been there, got the therapy bills to prove it.
Exactly. Now imagine, instead of that, you just type into a chat window, "Hey Claude, what's going on with the payment gateway service and who's on call?" And it just tells you. No clicking, no context switching, just answers.
And it's not just telling you, it's actively doing things, like handing the actual pager to an LLM. That's the wild part. I saw that announcement from Incident.io about the remote model context protocol server, and my jaw just about hit the floor.
Yeah, from vibe-coded to enterprise, handing the pager to Claude, that's the headline we're dissecting today. Because on March 31st, Incident.io officially rolled out something that feels like science fiction, but is very much real. A remote server that lets AI assistants tap directly into your live production incident data.
And not just tap in, but query incidents, analyze alerts, check schedules, manage escalations, essentially becoming your co-pilot or maybe even your primary pilot during an incident. It's a huge shift.
It is. This remote MCP server, hosted at https://mcp.incident.io/mcp, is essentially what they're calling the USB-C for AI, which, makes sense as an analogy. Just plug in your AI client, Claude Desktop, Claude Code, Cursor, point it at this URL, and boom, your LLM now has access to all your incident data.
The USB-C for AI is actually a fantastic analogy. Because what Anthropic did with the Model Context Protocol back in late 2024 was create a universal standard. Before this, every AI assistant needed its own bespoke integration for every tool. It was a nightmare. MCP acts like a universal adapter, making it plug and play.
So when you ask Claude, "Show me all critical incidents from the last week," the MCP server translates that natural language into the correct REST API calls, fetches the data from Incident.io, and formats it for Claude to present back. It's not magic, it's just incredibly clever abstraction.
And that abstraction is the key to killing what they call dashboard fatigue. We've all been there, right? Sevo, Slack's blowing up, you've got Datadog, PagerDuty, Jira, your internal wiki, and Incident.io all open. And you're just frantically flipping between tabs trying to piece together a coherent picture.
The psychological relief of not having to manually click through 10 different UIs at 3 a.m. to figure out who's on call for the payments gateway, that sounds like a dream. No more, "Wait, is this the right dashboard? Did I refresh?" Just ask Claude directly.
Absolutely. Imagine asking how many P1 incidents did we have this quarter and which teams were most affected? Or what's the trend in overnight responder workload by alert source? And getting an immediate synthesized answer? That's a game changer for incident postmortems alone, let alone active incident response.
But here's the thing that gnaws at me a little. If the AI is giving you this beautifully summarized, consolidated view, and you're not clicking through the dashboards yourself, are you losing that intuitive understanding of how the underlying systems are wired together? That muscle memory of where to look, what each metric means, how the pieces fit?
That's a really good question. It's the classic trade-off, isn't it? Convenience versus deep understanding. I mean, do you really understand how your car works when you press the start button? Probably not as well as someone who had to crank it by hand. But it gets you where you need to go faster. The worry is when it doesn't get you where you need to go and you don't have the fundamental knowledge to debug it yourself.
Right, and this entire journey, this enterprise-grade remote server we're talking about, has a fascinating origin story. It didn't just spring fully formed from a strategic planning session.
Oh, the vibe-coded part of the title. That's one of my favorite bits. The first version, a local Golang MCP server, was released in August 2025, and it wasn't even on Incident.io's official product roadmap.
No, it was built by their CMO, Tom, and an engineer, Chris Evans, because they wanted it to exist, not because we had a roadmap requirement or huge customer demand. They just built it. And they candidly slapped a warning on it. Fair warning, this is largely vibe-coded and unsupported.
Vibe-coded. I love that term. It perfectly captures that trend of building software intuitively and rapidly, leaning heavily on AI generation tools like Claude Code or Cursor, rather than going through the traditional, rigorous software engineering practices.
Incident.io themselves are apparently all in on this. They even admitted to vibe coding a custom game called Pagertron for Anthropic using Claude Code. They said, to think that you can build a simple game like that with a database of high scores without understanding very much about how it works is insane. Which, is a bit terrifying when you think about production systems.
It is. It reminds me of the early days of scripting, where you could cobble something together that worked, but it was held together with duct tape and good intentions. This is like that, but with a super-powered AI generating the duct tape. And while it's fun for prototyping, there's a dark side. A Retool engineering blog post from last year warned that vibe-coded apps are fun to build, painful to run.
Yeah, that's been my experience with some of the early AI-generated code I've seen. It's notorious for adding tech debt, being verbose instead of refactoring, and potentially introducing security vulnerabilities like secret leakage and injection flaws. Because the AI isn't understanding security best practices, it's just generating code that looks like it works.
Exactly. But here's the kicker. That vibe-coded prototype proved the market demand. Customers actually used it, a lot. But the architecture was fundamentally unscalable for enterprise teams. Running a GitHub repo, setting up .env files with raw API keys, Go run or Docker compose locally, forget about it for a large organization.
So the customers told them, we love the idea, but we can't adopt something that runs locally and isn't officially supported. Which brings us back to the March 2026 release, a fully managed remote server with zero local setup. No repo to clone, no API keys to fuss with locally, up and running in under a minute. They officially deprecated the old Golang implementation.
It's a fascinating product pipeline though, isn't it? Use AI to rapidly prototype a feature over a weekend, get community validation, and if it sticks, then rewrite it properly and productize it. If it fails, you just drop it. It feels like a supercharged version of Agile, maybe hyper-agile?
It's like extreme lean startup methodology applied to engineering. Instead of months of product management and design docs, you just build a working thing with AI in a weekend. It's almost bypassing the traditional 6-month product cycle entirely. The question is, does the initial vibe coding tech debt ever truly get paid down? Or are we just building a house of cards faster?
Well, that leads us directly to the elephant in the room when you give an LLM read-write access to your production incident management system. The prototype's authentication was a raw incident.io API key and environment variables. If that key had admin privileges, the LLM effectively had admin privileges. That's a massive risk.
Yeah, a classic security anti-pattern. If you accidentally commit that .env file or your local machine is compromised, you've just handed the keys to the kingdom to, well, anyone. The March 2026 remote release, thankfully, completely overhauls this with user-based OAuth.
Which is a huge relief. When a human connects via an AI assistant like Claude, they authenticate with their incident.io account using OAuth. The MCP client handles the flow, and the user approves access in their browser. This is the critical detail. Actions are attributed to your user account, and you see the same data you'd see in the dashboard.
So Claude isn't some autonomous agent with its own service account. It's acting as a direct proxy for you. It inherits your permissions. If you can only read incidents, Claude can only read incidents. If you can close them, Claude can close them.
Which solves the authorization problem, but creates a terrifying accountability problem. Imagine this scenario. It's 4 a.m., you're exhausted, and you ask Claude to update the status of the database incident. Claude, being an LLM, hallucinates. It misinterprets the prompt, and instead of updating, it closes a Sev1 incident that's actively costing the company $10,000 a minute.
Oh no.
And because of that OAuth attribution model, the audit log will show that you, the human engineer, closed the incident, not Claude. The LLM essentially committed an action under your name.
Wait, really? So if Claude goes rogue, I'm the one on the hook? That's terrifying. Even if I approved the initial OAuth connection, the day-to-day commands happen instantly in the chat interface. There's no, "Are you sure you want to close this Sev1 initiated by Claude" pop-up.
Exactly. So, are we comfortable taking the blame for our AI assistant's hallucinations? Does the convenience of natural language outweigh the precision and safety of a rigid UI with confirmation dialogues? Because right now, it feels like we're trading precision for speed and hoping the AI doesn't screw up.
That's a tough question, because on one hand, the natural language interaction is so compelling, but on the other, the stakes during a Sev 1 are incredibly high. Oh, my AI hallucinated and cost us $500,000 isn't gonna fly with the CFO.
It certainly isn't. And this shift away from rigid UIs and towards natural language isn't just about incident.io. It signals a potential end to an era. For the last decade, Slack and ChatOps have been the undisputed command center for incident response.
Ah, yes, the ubiquitous @incident declare, @incident update status equals investigating, @pd trigger commands. You had to memorize all that syntax. It was like a mini CLI within Slack.
Right. But with MCP servers, AI tools are starting to replace Slack as the primary interface for actual action. Instead of memorizing slash commands, you just say, draft my on-call handover notes to post in #handovers, or declare a new high-severity incident called database performance degradation, or who's on call for the platform team right now.
So Slack is moving from command center to more of a notification board. The actual thinking, querying, and action taking are moving into the LLM context window, which makes sense for developers who don't want to leave their IDE during an outage.
Exactly. Think about tools like Cursor integrating MCP. An engineer can be looking at a failing block of code, highlight it, and tell the IDE, create an incident for this, page the platform team, and attach this stack trace. It's an IDE-driven operation. That's powerful.
And it's not just within proprietary tools. Zapier recently launched an MCP client by Zapier, which means you can use any remote MCP server within Zapier workflows. So you can chain AI tools together without writing any glue code.
Like a Zapier workflow that triggers on a new incident, automatically uses the MCP server to find who's on call, then executes subsequent actions. This is where it gets really interesting for broader automation beyond just a single chat window.
So is Slack dead for DevOps? The incident.io changelog even noted you can use the MCP server to draft handover notes to post in Slack. It's basically saying Slack is just the broadcast medium, not the brain.
I don't think it's dead, but its role is definitely evolving. ChatOps forced you to learn a specific CLI-like syntax, which was a barrier, but also a guardrail. You couldn't accidentally declare an incident with a typo in the team name. MCP lets you talk like a human, but does that ambiguity of natural language become dangerous when managing a Sev 0?
That's the core tension, isn't it? The rigidity of ChatOps, well, sometimes frustrating, might have actually prevented mistakes during those high-stress, sleep-deprived situations. Now we're relying on the LLM to interpret our intent perfectly.
And that brings us to the future implications. This remote MCP server isn't just about making Claude smarter. It's the foundational plumbing for fully automated site reliability engineering.
Automated SRE, that's a term that gets my spidey sense tingling. Incident.io has explicitly stated they're building an AI SRE, currently in private beta. Their vision is an agent that will investigate the incident with you, show you what's wrong and why it's wrong, eventually will show you how to fix it or offer to fix it on your behalf.
That's the dream, isn't it? An agent that can detect an anomaly in Datadog, declare an incident via incident.io's MCP, page the right team, and then draft the preliminary postmortem in Notion, all without human intervention. That's not science fiction. That's what companies like Block are doing with their Goose agent.
Yeah, Goose was described as a production tool that automates triage and root cause analysis. So the pieces are already in place. And to inject a little levity into this slightly terrifying future, I have to mention Incident.io's joke integration.
Oh, the mind control protocol?
Yes, right there on their integrations page, alongside their real integrations, they list the Mind Control Protocol, the original MCP. Beam the incident summary directly into the head of your on-call engineer. No Slack, no PagerDuty, no excuses. And next to that, the Ouija board webhook with latency indeterminate, strongly discouraged for production workloads. They clearly have a sense of humor about the future.
They do, but it also highlights the ultimate trade-off we're making here. If we remove all friction from incident management, if an LLM automatically reads the logs, summarizes the impact, and pages the team, do engineers lose their operational muscle memory?
That's automation complacency, right? When the pager goes off and Claude hands you a neatly formatted summary, are you going to double-check the raw logs, or are you just going to blindly run the mitigation script Claude suggests?
Exactly, because if the AI SRE confidently states the database is out of memory due to the new deployment, and the human engineer anchors on that conclusion, but the AI is hallucinating and the real issue is a network partition, your time to resolution is going to skyrocket because you trusted the machine summary over the raw telemetry.
It's the ultimate test of trust. Do you trust the black box that summarizes, or do you trust your own ability to piece together the raw data? And how much time do you have to do both during a critical incident? It feels like we're trading one type of toil for another, where the new toil is constantly verifying the AI.
This whole thing is a fascinating evolution, from a vibe-coded weekend project to a full-blown enterprise solution that's reshaping how we think about incident management. It's clear that AI is going to deeply integrate into our operational workflows.
It is. The key takeaway for me is that the Model Context Protocol is truly a game changer, acting as that universal translator for AI to interact with all our operational tools. It finally makes AI agents truly actionable in the incident response context.
And Incident.io's move to a remote managed MCP server is what pushed this from a cool experiment to something enterprise teams can actually adopt. It shows how quickly AI-driven prototypes can evolve into critical infrastructure.
But we have to be acutely aware of the new risks. The human proxy model with OAuth means you own the AI's mistakes. That's a massive shift in accountability that we need to bake into our processes and our culture, not just our tech.
And finally, this is going to fundamentally change how we interact with our systems during an incident. The days of a rigid chat ops might be waning, replaced by natural language interfaces that are more convenient, but also carry the inherent risk of ambiguity and automation complacency.
So, as listeners think about this, what happens when the AI is wrong? When Claude hallucinates during a Sev1, who ultimately pays the price? The engineer who asked the question, or the company that deployed the AI?
And finally, this is going to fundamentally change how we interact with our systems during an incident. The days of rigid chat ops might be waning, replaced by natural language interfaces that are more convenient, but also carry the inherent risk of ambiguity and automation complacency.
So, as listeners think about this, what happens when the AI is wrong? When Claude hallucinates during a Sev1, who ultimately pays the price? The engineer who asked the question, or the company that deployed the AI?
And are we preparing our engineers for a world where their primary interface during an incident is an LLM? And not the raw dashboards? What skills will they need to maintain when so much of the traditional legwork is automated away?
That's a wrap on this debug log. Join us next time for more engineering war stories and hard-won lessons. If any of this hit close to home, subscribe and tell your team.
Ship it carefully.